Okay, now, continuing on to page 316, we've been talking about square roots, right? And I'd like to give you a little bit of insight about cube roots now, because I think cube roots will add to your depth of understanding. I want to start with something like the cube root of 27. The cube root, the little 3 here in the square root sign means it's a cube root. And a cube root of 27 means what would you have to cube, that is raised to the 3rd power, in order to get 27? Is there a number that you can cube and get 27? What would it be? 3. Okay, so the answer is 3 because 3 to the 3rd power would be 27. Okay? Now, did I just pick that number at random, or did I select that number carefully before I gave it to you, do you think? I didn't just pick that number at random. I have to be very careful when I pick numbers for cube roots. In fact, there are certain specific numbers that I should mention. Remember, before we started talking about square roots, we talked about squares, didn't we? Perfect squares. So before I get very far into cube roots, maybe I better make a list of the perfect cubes. What are the perfect cubes? 1 cubed would be 1. 2 cubed would be 8. 3 cubed would be 27. 4 cubed, now that'll slow you down a little bit, won't it? 4 times 4 times 4 would be 64. Good. And then 5 cubed would be 125. Okay? Now, can you do a cube on the calculator?
Yeah.
Can you do a cube? You can, can't you?
Yeah, you just multiply a number 3 times.
Okay, you could say 5 cubed is 5 times 5 times 5. Do you have an x to the y power button on your calculator? If you do, then here's a way to get 5 cubed. Using the calculator to do 5 cubed. I want you to do this. Take 5 and then hit you probably have a button that says y to the x, do you? You press that button, and then you give the calculator the power. 3, and what do you get? Equals.
125.
And you get 125, all right? That's how you raise to the 3rd power. Okay? Now, what if I started with 125, and I want to go back to 5 cubed? I want to go back to 5. In other words, what if I gave the problem like this and said the cube root of 125? Can you do that with a calculator? Is there a special button on your calculator somewhere that you can use to take a cube root of this? Now, this is going to vary from calculator to calculator, but most of the calculators, you start with 125, and then we have to do something right above the y to the x power button, I think, in most calculators. You're going to have something that says y to the 1 over x. Do you have a y to the 1 over x? Or sometimes it'll say the xth root of y.
I have a 1/x.
1/x?
Yeah.
Is it y to the 1 slash?
No, it
It's
doesn't
just
say y at
1
all.
slash x.
Yeah.
I doubt that.
X with 1 slash
You have an x to the 1 slash y? That'll do it. If you got an x to the 1 slash y, that'll do it. And it's probably somewhere near that x to the y to the x power button. Okay? Now, if you found that button, let me do this with you. Then, in order to get to this function that's off the calculator, what are you going to have to do? You've got something on the calculator called a second function, or a 3rd function, as the case may be. Some of you may have a cube root button on your calculator, and it may be the 3rd function where you have to do that. So in order to access this function, you'll probably have to say second function, and then press the y to the x power button. And then you'll have to tell it what root. You see, give it the 3rd root. Like 3, tell it that it's a cube root now, and then equals. Okay? Did that work? Let me stop and look at some calculators here and see what we've got. Now, as I stopped and talked to some of you about your calculators, I can see that there's no one explanation that's going to do for this, because everybody's got different calculators, and taking a cube root is a tricky thing based upon what your calculator wants you to do. Some calculators you have to enter the cube root first and then the 125, and some of you have to enter the 125 and then you do the cube root. So this is going to vary from calculator to calculator. So if you're watching this by video, you need to get out your instructions manual or go find somebody that can help you use your calculator to do this particular problem. Now the next thing I wanted to do is talk about this function of the cube root of 125. Let's start off with 5 and cube it. Okay? Do that again. Take 5 and then it'll be x to the y power and then 3 and then equals. And you get 125, right? Now what I want you to do is undo the cubing process. And this will help you understand what a cube root is. What is a cube root? A cube root is just undoing a cube function. Okay? So if you just cubed 5 and you end up with 125, now I want to go back to what I had before. You see, I want to undo that. It's like if somebody gives you a present, they take that present and they wrap it up, don't they? They wrap the present. And they give it to you, and then what do? You unwrap the present. All right? And then what do you end up with? The present and a bunch of paper. Okay? Well, you start, they start with a present, they wrap it, and then they unwrap it, and you're back to the present, see? So this is as simple as wrapping and unwrapping a present, isn't it? Okay? So if you started with that 125 and you want to go back to the 25, what we have to do is do the cube root. So you've got this function right here, y to the x, and then right above it is this thing called the second function. This extra function that is the opposite of whatever this function was. Usually that's the way it is on the calculator. So that's why I said, look at the top left-hand corner of the calculator for second function, and that's how you access that. So if you've got 125 in the calculator, most of the time what you're going to do, you can take that 125 and press the second function key, or the shift key, or the inverse button, and then the x to the y, and that's going to activate the x to the 1 over y, or maybe the x root. Your calculator probably doesn't say x root of y, it says x root. Then you have to tell it what root, whether it's third root or fourth root or fifth root. Let's try one more problem then, and what you'll end up with is 5, right? Equals, you get 5. But I want to take the fifth root of 32. The fifth root of 32. Okay? So let's start with what? 32 for the first number, and then we'll have to take, and we want to take the fifth root, so we'll have to activate that second function key, whatever you do to activate that second function. A couple of you I talked to are going to have to do the 5 first before you activate that function, and then you'll be given it the 32. But most of you, I think, are going to take 32, then you're going to do second function, and then you're going to do what? Y to the x power. And now you have to tell it what root you want to take. What root do we want to take here? Fifth root. Okay? And then equals, and what do you get? 2. Okay? So what you just did the fifth root of 32 is equal to 2. Okay? Now when I was learning how to do this, we had no calculators around. I had to learn this the hard way. The calculators is really a neat way to do this. And you can use the calculator to help you understand the concept of what it means to take a fifth root. Okay? So in this case, in the old days, what we'd have to do, we'd just have to trial and error. Just try numbers until you could find a number that you could take times itself 5 times, like 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so 2 times itself 5 times. would give you 32. So the fifth root of 32 would be 2. That's the idea. Okay? Any question on that? All right. Now, suppose you have at the bottom of that page, now that you know how to take a cube root of all these numbers, suppose you have to take the cube root of x to the 6th. Cube root of x to the 6th. Any guesses what that might be? What about x squared?
If you take half.
How would you know for sure that this is true? How would you know that the cube root of 125, now we know that the cube root of 125 is 5, but how could you check it without a calculator? How could you check this to make sure it equals 5? We'd have to take the 5 and do what? Raise it to the third power, cube it, and that would give you back 125, okay? So how can we check x squared? X squared and do what? Cube it to the third power. And what would that give you? X to the 6th, and therefore that's the answer, right? X to the 6th. Now, you don't have to go through all this checking stuff. If you can find a nice little thing that works, what looks like it might work if you're doing 3 cube root of 6 and you want to get x to the 2nd. Is there a pretty obvious way to get that answer? You divide, right? Now, remember what I said, that a root is the opposite of raising to a power. A root is the opposite of raising to a power. And you remember this rule that we had, if you had x to the 2nd raised to the third power, what's the rule when you have a power raised to a power? The law of exponents. You multiply exponents, don't you? So if when you raise a power to a power, you multiply exponents, doesn't it seem reasonable that when you take a root, you'd be doing the opposite thing, which is dividing exponents? Yes, isn't that neat? So all you have to do is just remember that when you divide, when you have a root, you divide exponents because it's the opposite of raising to a power. All right? So what if I had something like number 16, which says the fourth root, this is on page 316, and it says the cube root of x to the 12th. That doesn't either. It says the cube root of x to the 12th. Let me get on the right problem. Yeah, the cube root of x to the 12th. So what would be the result? X to the 4th. And if you wanted to check that, which you may not, but if you wanted to check it, what would you have to do to check it? Take the x to the 4th and raise it to the third power, which is like multiplying exponents, right? And you'd end up with x to the 12th. That's it. Okay? Any questions on that? All right? Now that's how you take a cube root, or a fourth root, or a fifth root. Now let's go on over to the next page. And number 23 says the 8th root of x to the 40th. 8th root, did we do any 8th roots in here? I don't remember doing any 8th roots. Wouldn't it be the same rule? What would you put? X to the 5th. Because when you take a root, you divide exponents. Now, wait a minute. Now, what was the square root of x to the 6th? The square root of x to the 6th? Square root of x to the 6th. X to the 3rd. What was the rule we had for today? When you do a square root, you divide the exponent by 2. Now, what you could do if you wanted to, you could think of this as being a second root. A second root. You could think of a little 2 being there. Usually we don't put the 2, but there's assumed to be a 2 there because it's a square root or a second root. So you see you divide the exponent by 2. That's how we get x to the 3rd, by dividing the exponent by 2. Okay, now down the bottom of page 317, I have some more cube root problems for you. These cube roots don't come out even. So look at a problem like, well, let's go on over to the top of the next page. Number 33. Number 33 says the cube root of 72. The cube root of 72. What perfect cube, by the way, you have to do this assignment, you're going to have these numbers 8, 27, 64, and 125, you're going to have those four numbers in the front of your brain. And if they're not in the front of your brain, put them in front of your eyeballs so you can see them. But we're going to have to build everything based upon these numbers. One of those numbers divides evenly into 72. I want to write two separate cube roots, and one of them needs to be one of those 4 numbers over there. What's the perfect cube? 8, right? 8. 8 is the magic number for this problem. 8, and what would the other number be?
9.
9. 8 times 9 would be 72, okay? You see where I got that? See, I'm looking for a perfect cube, which are 8, 27, 64, and 125. I want one of those numbers that divides evenly into 72. And the number is 8. 8 goes into 72, doesn't it? 8 goes into 72 how many times? 9. Okay? Now, can everybody in here do the cube root of 8? With or without the calculator? The cube root of 8. You probably know what the cube root of 8 is, don't you? The cube root of 8 is 2. Now, how did you know it's 2? Because 2 cubed is 8. See, 8 is 2 cubed. So the cube root of 8 would be 2. And everybody knows that, right? Now, what would be the cube root of 9? Nobody knows. So guess what we do with cube root of 9? Just leave it alone. Just leave the cube root of 9. So it would be 2 times the cube root of 9. Just leave it like it is. Okay? Now, if you wanted the decimal value of the cube root of 9, you could do that. If you wanted the decimal value of the cube root of 72, you could do that, and that might be of more value to you. By the way, go ahead, as long as you've suggested it, go ahead, calculate the cube root of 72. Calculate the cube root of 72 for me. What would you have to do with your calculator? You'd have to put 72 in there. Second function, x to the y, y to the x, give it a 3, and then equals. What is it? 4.16016. It goes on and on, doesn't it? Okay. All right. Now, I want you to calculate this number for me. Take the cube root of 9. Take the cube root of 9. Right, 9, and then do the cube root. And when you get that answer, I want you to multiply it times 2. And see what you get. Does it come out the same? I hope. Cube root of 9, in other words, you're going to have to do, what, 9, and then you'll have to do y to the x. And then you'll do, I'm sorry, no, don't do that. Do 9, and then you'll have to do the second function. Remember the second function? Second function, y to the x. And then you'll have to give it the 3. And then equals. Okay, now that gives you the cube root of 9, doesn't it? Now do that times 2. Equals.
1 times 2.
Because I want to take 2 times the cube root of 9. Okay? And it comes out exactly the same, doesn't it?
Yes.
Okay? Comes out exactly the same. So that's one way you could check a problem if you wanted to. You could calculate the value of it in the original form, and then you could calculate the answer and see if it comes out exactly the same. Okay? All right, now, I want you to do a few of those exercises, and I think you'll be able to do those. Let me move to the next section so I can be sure to have plenty of time to talk about that. I want you to do page 318 through number 46 for next time. Through page 318, number 46. And there are extra problems if you want to go on beyond that you can do. I think doing a cube root really adds to your understanding of what a square root is all about. And that's the main reason I want to do this, so you'll have a deeper understanding. Now, beginning on page 320, we have operations with radicals. On page 320 comes the idea, what if you have 3 times the square root of 2 plus 5 times the square root of 2? then those are just like radicals, aren't they? Wouldn't this be, what if it was 3x plus 5x? What would it be? 8x. So what if it's 3 square root of 2's and 5 square root of 2's? They're exactly alike, aren't they? So what would you have?
8 square root of 2.
8 square root of 2.